We've been looking at the work of the very famous 6th century BCE Greek mathematician Pythagoras, who we know found a relationship between the two shorter sides and the longer side, the hypotenuse, of a right-angled triangle. What we want to look into is whether or not we can find a relationship between the lengths of those sides. Do we know three numbers which satisfy Pythagoras' equation, which, just to remind ourselves, is a squared plus b squared equals c squared, where a and b are the two shorter sides and c is the hypotenuse, or the longest side. If we can find these three numbers, we're going to give them a name and we're going to call them Pythagorean triples or triads. Three numbers, triples, triads, which satisfy Pythagoras' equation. By this time, you should have come across a set of at least one set of three numbers which satisfy Pythagoras' equation. Probably the simplest and most well known are the numbers 3, 4, 5. Let's see if 3, 4, 5 satisfy Pythagoras' equation. 3 squared plus 4 squared, does it equal 5 squared? 9 plus 16 does indeed give 25. So we can call 3, 4, 5 a Pythagorean triad, or triple, because it satisfies Pythagoras' equation. But let's look into it further. If I know any Pythagorean triple or triad, I can create an inordinate number of additional triples or triads simply multiplying each side, each part of the triple, by the same constant. For example, we could say 6, 8, 10 is also a Pythagorean triple. How have I created that? Taking the basic 3, 4, 5, I've multiplied by 2. 6 squared is 36, 8 squared is 64, 10 squared is 100, 36 plus 64 is 100. Do you know any other common Pythagorean triples or triads? Here's a few that you should know. 5, 12, 13. 8, 15, 17. 7, 24, 25. All these sets of numbers are Pythagorean triples or triads because they satisfy Pythagoras' famous theorem. Try it out. Make sure you are a believer. Are there any others that you can find out? I'm going to give you a way to find some out. Here's an algebraic way to determine or create any number of Pythagorean triples or triads. Say we have two integers m and n, where m is greater than n. Here's a way of creating a Pythagorean triple or triad. The three sides can be found by finding 2mn m squared minus n squared and m squared plus n squared. For example, take the integers 6 and 5. 6 is greater than 5. So using the example of the relationship mentioned before, I have to find 2 times 6 times 5 is one of the shorter sides. The other shorter side is 6 squared minus 5 squared. And the longest side, or the hypotenuse, should be 6 squared plus 5 squared. So in this case, a Pythagorean triple, or triad, would be 60, 11, and 61. Let's see if 11, 60, 61 fits. You better have your calculator ready. 11 squared plus 60 squared needs to be equal to 61 squared. 11 squared is 121. 60 squared is 3600. And 61 squared is 3721. It's pretty cool. Try it out. See if you can create some Pythagorean triples or triads. Make a list in your book.